So we'll talk about microbiome and digestive health science. So the gut microbiome, it's a big field. We have all these microbes that live within us. Some are good, some are bad. And they live in a delicate balance. But we have more bacteria than human cells. And I joked with my wife when she's like, yeah, I'm eating for 2, I got to eat more. And I'm like, no, you're eating for trillions, We have more foreign stuff inside of us. If you ever need a complaint or a reason to eat more food, just be like, hey, I got to eat for all the bugs that are living inside of me. I mean, and they're growing, they're dynamic. We have our own signature. Your microbial signature is different from mine based on diet, lifestyle, health, etc. And it's complex. There's no agreement in the scientific community of what is the optimal microbiome for all of us, because what we're finding out is that maybe a personalized approach is actually better, because what works for me may not work for you and vice versa. And so and that's one of the limitations we'll talk about today with probiotics, is that they're studied for specific issues, but these are specific strains that they're not personalized to the body, right? They're not growing different types and varieties of healthy bacteria in the body versus different ingredients that might approach this in a better way. When it comes to digestive discomfort, it's very common, especially in women, at least women that admit to digestive discomfort in surveys that are passed out. Maybe us men are a little bit more stubborn and we don't like to admit to these things, but in my opinion, both men and women do struggle from a lot of these things, from bloating to gas, diarrhea, cramps, pain, constipation, stool changes, pain, all the above. And these can all be indicators of a disrupted microbiome, right? They call it dysbiosis science, where just the microbiome is out of whack because of some factors that we'll talk about today. So everybody thinks, okay, my gut's out of whack, it's not doing good, I'm having digestive symptoms, I should go to the store and get a probiotic. Well, that's great. It's a good start. But do they really consider all of these things, right? How acidic a product is? If it has a low pH, the acid actually kills off the probiotic or the bacteria. If it has other bacteria, they compete for survival. And we've actually seen that from our own testing. What about the level of oxygen in a product? If you don't control for that or account for that, oxygen is going to degrade the probiotic that's naturally found in the food or the supplement. Food processing and storage. This is actually a very big deal, because I've seen our own internal data on different probiotics. We have one that we sell that is resilient, it's very strong, but in general, not all probiotics are created the same. And in order for them to be effective, they need to be given in an effective amount. So even if you go to the store and get some yogurt and you're like, oh, it has some probiotics. Well, I asked the consumer, well, is it doing you any good? Is it correcting the digestive complaints that you have? Or, just a lot of consumers think, oh, I take a probiotic, I don't need it. And well, maybe because of these reasons and more, well, food processing and storage, by the time it actually gets to the consumer, because the probiotic has degraded so much, it may not be in a viable concentration that's providing a significant benefit to the person that's taking it. And then ability to colonize in the gut, right? So for a probiotic to be effective, it has to bypass the gastric acid in the stomach, right? Which has a pH of about 1 to 2. It's highly acidic. I mean, you have bile that's not quite as acidic, and so it all mixes together in this clump in the stomach. However, in general, if it can't do this, and there are viability studies on probiotics showing that some are better than others, and in fact, a lot of them are very weak. And in the presence of acid and other compounds, they actually show that they just pretty much disappear where they don't survive. And so if they can't survive and can't colonize, as a probiotic, it does you very little, if not no good, inside of the body. And so there must be a better way. And so we've looked at this, and we have a unique solution with prebiotics, okay? These are nutrients that help the microbiome thrive, and we'll talk about these. Probiotics, this is a different category that we didn't include. They still have their time and place, don't get me wrong, but these by far dominate the industry and the marketplace for digestive health, right? Consumers are familiar, they know probiotics, oh, they're good for you, but they don't usually realize that, oh, well, different strains of probiotics are studied for different things and different outcomes. They don't all do the same thing. In fact, they vary widely in their effects and how effective they are. And then postbiotics. So this is kind of a new term. These are metabolites or substances or compounds that are actually produced by the bacteria. So this is kind of the metabolism of the probiotic or the compound that's found in it, where even if it can be heat killed or destroyed, the compound lives on. And so this actually provides some unique opportunities in the science to be able to leverage those ingredients. So going back to prebiotics really quick, a lot of us don't get enough fiber in our diet. Fiber, you can see average intake is around here for men, or for women, excuse me, that disappeared. And then for men, we're deficient by about 10 here. Here's the gap, by about almost 10 to 20. Average intake for women is usually a little bit lower. For men, it's a little bit higher. But either way, there's a big gap. And most of the fiber sources that we get in the American diet actually come from whole grains. And I should clarify that not all not all fiber are prebiotics. And in fact, not all prebiotics are fiber. And let me stand back and try to explain that. Prebiotics, by definition, are non-digestible ingredients that have been shown to shift the microflora and provide a benefit to the host. Most prebiotics are from fiber, but some are not. There's actually some novel studies coming out that other compounds beyond just fiber can actually shift the microflora and have prebiotic-like activity. That being said, most of the sources just come from, apples or bananas or onions or whole grains. Bananas, interesting tidbit that I learned recently about this is that it's the green bananas that actually have higher levels of prebiotics. When they turn yellow, so some of those sugars, they separate. I mean, that's what a prebiotic is. It's pretty much sugars that are bound together that makes it undigestible by the body because it has links. And when they separate, the banana becomes sweeter. So it usually tastes better and people wait till they're yellow, but the prebiotic content is a little bit higher in the green. In any case, I've seen studies and estimates of average intakes of prebiotics, and they're usually in the small gram amounts per day. And that makes sense because you're only going to get a few grams per 100 grams for a lot of these major food sources that actually contain prebiotics in the first place. And so concentration of prebiotics in diet alone is very, very small. And what I'll mention about that is that most of the prebiotics as well are fructose or glucose based. So things like, inulin or fructooligosaccharides, right? Different prebiotics that you've heard about maybe. Well, these are largely fructose based. And so you have these fructose compounds that are bound together. And when they go through the digestive system, yes, they can actually increase some of the bacteria in the body, increase some of the good and increase some of the bad for that matter. They're not quite as selective. But at the same time, with the fructose, too much of that can cause some of the digestive upset, right? And those are the things that consumers are trying to correct in the first place. And so I just want to make it clear from the get-go that not all prebiotics are created equal. So we'll talk about the one that we chose, XOS. So xylo-oligosaccharide, these are prebiotic fibers that have a different structure to them that provide unique benefits at a very low dose. We have BPO1 as a postbiotic, healthy energy with caffeine, so 50 milligrams per packet, and then antioxidant protection from pomegranate. So let's start out and talk about XOS, because this to me is the hero ingredient. I'm a big fan of it. We don't get nearly enough, not even close, from diet alone, unless somebody here is eating bamboo all the time. I don't know, you guys chugging bamboo? Probably not. In any case, XOS, so it's effective even at a low dose. There are studies at about 1 gram or even a little bit lower showing that it can shift the microflora and improve digestive health. Very, very strong, very powerful. And it deals with the unique chemistry that we can get into. But when you compare that to other sources, they usually recommend about 5 to 10 grams or even more to shift the microflora and improve digestion. And so this is to me is really a super prebiotic that we need to get out there. It selectively promotes beneficial bacteria in the gut. This to me is important because if you're getting a lot of the stuff that's growing the good and growing the bad, it can be helpful, but it can also be harmful, right? We have all kinds of microbes that live within us, right? Staphylococcus, streptococcus, Clostridium. We have so many different kinds, and we have good kinds too. Bifidobacteria and lactobacillus are usually the 2 key categories of the ones that are considered to be good based on the science. These are very, very selective for increasing the growth of bifidobacterium. And by increasing bifidobacterium, I mean, there's 30 plus types of bifidobacteria bacteria that we have inside of the body. And so it's very personalized and selective, which I love that word. Supported by clinical studies, well tolerated due to low effective dose, and it's all about a balance. So these are just a few of the studies here. This is one in 20 healthy subjects. It was 6 weeks. They were given 1.2 grams of XOS, so about a gram, and a rice porridge once a day, and then 10 got a placebo, and they evaluated the effect on the gut microflora, and you can see that there were increases in lactobacillus and bifidobacterium and decrease in clostridium. So it's increasing the good and decreasing the bad. This to me is because it's very selective. There's only so much room in your intestines to actually colonize microflora, right? So by nature, if you are increasing the good stuff, there is less room for the bad, and so it helps to eliminate the bad ones. This one is actually linked with inflammation and infection, specifically in the body. This study over here is in 56 women. It's a double-blind study for 6 weeks. They took 10 grams of sucrose, which is just table sugar, with 0.7 grams of XOS. So a little less than a gram, very, very small dose, or 10 grams of sucrose as kind of your placebo group or control group. And then they looked at bowel movements. And you can see at the beginning of the study, I mean, if you're going to the bathroom twice a week, there's probably something going on in the intestines, right? We need to correct that and fix that. With a low dose, even at just 6 weeks, there was a significant increase in the number of bowel movements to help correct that deficiency that was happening inside the body. This was a significant improvement. It was published in 2015. Although not shown here, there are other studies that show on the reverse side of the equation where bowel movements were too frequent and they were going and they had more liquid stools. They show that there was a reversal of that, bringing it back to normal. And so what I would tell people is that regardless of which area you are on the spectrum, this prebiotic fiber can help with regularity. The other point here is that there was another study that was published. There's a lot of studies, but another one showing that there was a significant improvement on the ease of bowel movements as well. So just for bowel comfort, bowel regularity, there's some really, really nice studies, even at low doses of this XOS. This is another study showing the ratio of Bacteroides to firmicutes. This is in a healthy population. What I'll mention about these two is that the firmicutes are generally considered the bad class of bacteria, okay, or the bad group of bacteria that live inside of us, whereas the Bacteroides are generally considered good. So good, healthy populations, healthy weights, they usually have higher amounts of this and lower of this. After 8 weeks in this population, given 2 grams, so it's a little bit higher dose in this case, but they showed a significant shift in the microflora where this was increased and this was decreased. Tolerability was also really good in this study. So subjects didn't report any kind of side effect, which is very, very common in a lot of the fiber or prebiotic fiber studies that you'll see in the marketplace. New science on postbiotics. So what are postbiotics? This is kind of a new term. To simplify it the best way I can think of, postbiotics are probiotics that have been heat killed that still maintain some benefit because they have a compound or a metabolite that it produces or that it contains that provides a benefit to us, okay? The advantage of this is that you can heat kill the probiotic and maintain it as a postbiotic, and you don't have to worry about the stability issue of the probiotic degrading over time because you've already maintained that compound and it stays very stable throughout its shelf life. So you can actually end up using this in a wide variety of different packaging. It doesn't need to be refrigerated, and you don't have to worry about that sharp degradation that happens over time with probiotics. And so it really is a new, novel, exciting area in the research. There's more and more of this coming out. I mean, when you look at PubMed and postbiotics, you're probably not going to see much of anything before the year 2000, but from 2010 and on, the research has really exploded, and it continues to increase. So a lot of advantages and cool effects here. BPL1, it's naturally occurring. It's isolated from healthy humans. It's actually from healthy breastfed infants, backed by scientific background. It works as a live or a heat-treated, but in some cases, the heat-treated can be more effective. So this was just some preliminary research behind why this particular source was selected. So the BPL1 significantly reduced lipids in C. elegans. So this is a worm study, and had the greatest reduction compared to 23 lactobacillus, shown in the full paper, and 15 other bifidobacterium strains, shown below. So you can see, these different strains that all had, and these are estimates of lipid metabolism inside of C. elegans. They use fluorescence. So under light, you can actually use it to estimate. And the higher amount of fluorescence is indicative of reduced levels of lipids in C. elegans. And so there was a really fun screening process finding that this one was the best Over here, you can see in this bar graph, you have a control group, you have the live, and then you have the heat treated. This is just showing that the heat treated versus the live have a very similar effect on lipid metabolism. So for this particular probiotic or postbiotic, it didn't matter which form you actually used. Caffeine. This is another ingredient that a lot of people consume. I was reading a paper that estimated 90% of us drink caffeine on a regular basis in America. So it's commonly used, it's very safe, but it's also effective for performance, alertness, focus. This is one study where they gave it to well-trained athletes. They did a 2.5-hour cycling test. We should bring out bikes, Stephen, and have everybody bike for a full 2.5 hours and see how well they do, see if they can last. Well, everybody here lasted for 2.5 hours at 60% VO2 max, and then they followed it up after 2.5 hours at 75% VO2 max. So this is like pushing it to the limit after 2.5 hours of being exhausted. And what they showed in this study is that even with a lower dose of caffeine, there was an increase in energy, in performance, and endurance. So that group lasted longer with the caffeine versus the other group. They also tested them before, during, and after exercise and found increased cognitive ability and their ability to actually accomplish these tasks faster without affecting performance. So kind of a mental edge, but also a physical edge from the caffeine. Pomegranate, it's a natural source. It goes through a hot water extract. Pomegranate's a very super fruit, in my opinion. It's something that we need more of. It's more than just a powerful antioxidant. In fact, some of the polyphenols in pomegranate aren't fully absorbed. And that's been one of the weaknesses in some of the early papers on pomegranate, saying, well, it's not super effective because of the absorption. However, in this case, what happens is some of the microbes that live inside of the gut, they actually ferment or use some of these polyphenol-based pomegranate ingredients, and they actually use them as an energy source to be able to support a healthy microbiome. And so this is actually kind of a complementary ingredient, and there's some really nice in vitro and a little bit of unpublished data at this point that really hints at this innovative approach to using pomegranate to also support the microbiome in addition to its antioxidant effects. Just some of the key benefits that we summarized here today, talking about the blend of ingredients together, right? It's all about these things, still did not have optimal metabolic health. So this is looking at metabolic parameters like glucose, insulin resistance, blood pressure, cholesterol, waist circumference, right? HDL cholesterol specifically. So a lot of us can improve. Are you getting enough from diet alone? Well, this is going to be your average intake around the world. In Australia, China, France, Spain, United States, there are actually several estimates. We usually range from about 10, 11, 12 milligrams a day. And this is counting total levels of anthocyanins. So on a regular basis, we're not getting a lot of these nutrients from diet alone. Let me back up here. Anthocyanins are a class of pigments that give a lot of the bright red, blue, and purple colors to fruits and vegetables. Who has a favorite purple food that they like? Can you? Eggplant, there you go. We're eating that on a regular basis in enough amounts, right? Purple corn, purple cabbage. I mean, how often do you see purple cabbage at the store, right? It's always green now, right? It's losing its nutrient value. And these bright colors are actually protective ingredients on the plants that are being lost from our food supply, right? Purple corn, right? All the corn that I buy at the store is yellow. Not seeing a lot of purple stuff. Even the blues, right? A lot of the blues are good too. You know, your bilberry, your blueberry, a lot of these good superfoods that we don't get on a regular basis or nearly enough, right? Based on some of the science and studies. Well, there's a wide variety of studies and doses that are used in literature. And this is, to me, is a really key mark based on our science and our research that we've done to show what is going to be an effective dose for overall metabolic health. Anthocyanins right here. So when they're rich in your diet, it helps to shift your body's biochemistry to a healthier mode. So when you look at a sampling of metabolic pathways and biological effects, I mean, we could talk about these all day, you know, CPT1A, RBP4, I mean, all of these going down the list. Usually we're not as familiar with mechanisms, even though they're in literature. We're more familiar with some of these metabolic pathways. So insulin sensitivity, glucose uptake, lipid accumulation, blood lipids, oxidative stress, right? And then you look at the fat, the muscle, pancreas, right? There are all these markers and mechanisms going on. And what was fascinating about the research is that if there is a metabolically healthy choice that we want to mimic our nutritional approach after, well, it would be exercise. You can see it in the bottom corner, right? So we have this healthy choice of exercise. Well, how does it impact these mechanisms or these biological effects in the body and these different tissues, right? Is it increasing these things or is it decreasing these things? And usually exercise as a model of anti-aging is one of the top things to do. What was fascinating about our discovery of these anthocyanins is that they are moving the needle in the same direction of a lot of these pathways and biological effects inside of the body as well. So when you look at the overlap in things that are happening, for example, let's just take insulin sensitivity and glucose uptake in the liver. You're going to see that same pattern with anthocyanins as you do with exercise. You know, what about in the fat tissue? You look at insulin secretion and glucose uptake or insulin sensitivity, right? You're going to see a lot of overlap there. Fatty acid oxidation, right? That's a good thing. When we talk about fatty acid oxidation, that's actually breaking down the fat cells where you have fat that is broken down into, you know, triglycerides and fatty acids, right? To be able to be used up in the citric acid cycle as a source of energy. So you're seeing that same movement in the fat tissue, right? What about skeletal muscle? You're seeing glucose uptake, insulin receptors, right? When you talk about the muscle, it's a very active tissue. It's dynamic. It actually wants to use carbs and glucose. And so you're actually taking that energy inside of the tissue with anthocyanins, similar to how you do with exercise. And then in the pancreas as well. The one thing that most of us can relate to is beta cell function, right? So you have these beta cells in your pancreas that secrete the insulin, and so it relates to insulin function in the body. Well, you can see an increase in that function with anthocyanins, as you can see with exercise. And so what I want to make clear here is that this is not exercise in a pill, right? There are differences, right? However, what I want to make it clear is that we were very impressed with how powerful and effective these anthocyanins can be in mimicking a healthy aspect of anti-aging in our body. And when I read the science, there are additive effects when you can actually combine exercise, all the better, right? Some resistance, some aerobic training with anthocyanins. You'll actually see a lot of research with black currants specifically out of New Zealand showing remarkable benefits on things like performance and recovery and things related to athletics and exercise. Okay, so the studies that led to the breakthrough, and I'm going to go through this rapid fire because I think I'm running out of time here, but let me just highlight a high level, just some of the studies that led to the breakthrough in our innovation behind these anthocyanins. So number one, this is a study looking at permeability of the cell. So you apply inflammation and it causes the cell to be more permeable. So that means more stuff is leaking through. However, with cyanidin and delphinidin, you can see that it essentially reverses the negative effect of inflammation on the permeability of the cell. However, the malvidin, the pituitidin, the pionidin, these are ones that are also anthocyanins, but they didn't have the same effect. And so in able to combat inflammation in the cell, we said, well, this was a unique discovery where we could then do other clinical testing to find out how these behave. And so we did this, and you can see here, we're looking at another marker of permeability. You can see that the high-fat diet with anthocyanins really attenuates that negative increase in permeability in the cell. We looked at endotoxins as well, that with the anthocyanins, it attenuates that negative effect as well. And so you're having less endotoxins that leak into the bloodstream. As part of this same clinical, we saw significant changes in the bacteria and the microbiome. You can see that there is a decrease in the ratio of firmicutes to Bacteroides. That's good. You want to decrease that ratio because you want to decrease the firmicutes and increase the Bacteroides. And so very, very powerful effect there. And then Akkermansia as well. It's another healthy class of bacteria that's linked to the body's metabolism, where you can see an increase with the anthocyanins, attenuating the negative effect of the high-fat diet. On another study here, looking at GTT and ITT, these are markers of glucose and insulin resistance. You can actually see some nice effects and changes with the high-fat diet with anthocyanins helping to reverse and attenuate that negative effect of the high-fat diet on the glucose control. So measuring essentially how much glucose is needed to bring it back to normal. And then with the insulin, you give the glucose as well and see how much insulin is needed to actually bring the glucose back into the cell. And you can see that there's a remarkable effect here with the anthocyanins. Down at the bottom, you can see in the liver. So you take pictures of the liver and you can see the control group versus the high fat. You can see a lot of triglycerides that build up inside of the liver. So that's when fat builds up around a tissue, that's what we call visceral fat, right? And then you can see with the anthocyanins, it really helps to reverse the negative effect of the high fat diet. These are the same diets. The only difference is the anthocyanins in this group helping to improve the body's metabolism, and a picture right there showing that the metabolism is more effective because the triglycerides, they're not depositing inside of the liver. This is a human clinical study that we did where we combined prebiotics with anthocyanins, and you can see that there's a dramatic shift. So this is obese individuals, so 46 people. If you remember these graphs from earlier, there was a difference in the starting point. For this particular study, it's a really high amount of firmicutes, but you can see they're healthy, but they're also obese. So their microflora is going to be a little bit different from a healthy younger or non-obese population, but you can see a shift where this is decreasing and the Bacteroides is increasing. As part of the same study, there was an increase in HbA1c well at baseline, and there was a decrease at the end of the study from anthocyanins. Something I learned recently is that when we submitted this paper for publication, this was not one of the primary talking points within the paper itself. However, what's intriguing to me is that when the researchers looked at this, they're like, you really need to call this out. Like, this is a significant finding. I mean, these aren't people that are even pre-diabetic in this study, right? They have healthy levels of blood sugar, but there was a reduction even in healthy obese individuals. So it's just helping to move that needle in the right direction and helping to improve overall glucose health in the body. Maybe one thing I'll mention about here is when we have glycated hemoglobin, that's the marker of long-term glucose, right? Because a lot of people are like, well, what's so bad about high glucose in the body? Well, over time, it can damage pretty much every tissue and organ that lives inside of you. But it creates this stickiness effect, right? Where the glucose, if it's not being managed well, then it begins to stick to proteins, right? Called hemoglobin and others. But for this one, we can actually measure. And hemoglobin is a protein in red blood cells that transport oxygen to the rest of the body. And so when it becomes more sticky, you have this long-term indicator of glycation that's happening inside of the body, which is an indicator of aging or accelerated aging, and something that we want to help improve or even reverse through supplementation. And then this is a human clinical study. This was actually just published. I have the reference down at the bottom for the abstract, but we toxins. So these are the endotoxins that are leaking, in the gut, that are getting into circulation. And these endotoxins can cause, inflammation and metabolic dysfunction. So it can be really bad. And you can see even with one meal, it was able to attenuate the response of endotoxins. So there's a very immediate impact there, in addition to an impact on glucose, where there was a lower glucose curve. In that same study, there was a lower triglyceride curve and a lower cholesterol curve. The cholesterol was almost significant with a p-value of 0.06 when I just reviewed the study, but it was still trending lower. So it's improving blood lipids, it's improving blood glucose response, and it's improving the endotoxin response, all on an immediate basis. In fact, this to me is my favorite study and very compelling evidence that a lot of people don't really think about what they eat. They're eating a lot of bad stuff all the time, super high fat, super high carb, super high sugar, and they don't even think about the consequence that even with that one bad meal, well, you start to build up all of these things. And then when you compound that with meal after meal after meal, right, that's what's leading to metabolic dysfunction in our communities today. And we're not on the right track. When you look at the numbers, we're moving in the wrong direction. And so this to me is very compelling. A few minutes here and I'll wrap it up. This is just talking about GI barrier function as an underlying factor. So this is going back to like the sources of aging and the sources of the problem, right? It's about inflammation. It's about oxidative stress. It's about insulin resistance, right? It's about mitochondrial dysfunction. We can talk about some of these key triggers and these cores, but it's really our modern lifestyle. It's shifting our microflora. It's altering these tight junctions. And what's happening is we're getting this leaking of stuff happening, right? We have endotoxemia leading to inflammation and metabolic dysfunction. By that, we're talking about, glucose, insulin, cholesterol, blood lipids, all the above. So the solution is, well, these anthocyanins, they're very superfoods. They can improve the microflora. They can adjust these things. They can promote tight junctions. So they're going to tighten up those intestinal cells. And in doing so, the result is, well, less endotoxins, better inflammatory balance, which is part of your immunity, and then also helping to support metabolic health in the end.